Welcome to the deep dive, where we unpack the most critical innovations right at the bleeding edge of technology. If you're tuned in, you've almost certainly felt the impact of AI in your daily life. And it's been truly, well, astonishing to witness how quickly everything has accelerated, hasn't it? Just a year ago, maybe 44% of developers were leveraging AI. And even Gartner's projections for 2030, predicting maybe 50% of knowledge workers using AI, they seem almost quaint now.
Oh, completely blown out of the water.
Yeah.
Today, we're seeing over 75% of knowledge workers already using AI for augmentation. And for developers, it's over 76%. That's huge. And this rapid adoption, it really reflects a fundamental shift in AI workloads. We moved from a primary focus on training these complex models to a primary focus on inference.
Inference, right. So
Yeah.
applying the AI rather than just building it.
Exactly. And this isn't just some technical detail. It fundamentally changes where the AI power is applied. It means AI is no longer just a back-end R&D thing. It's now front and center, ready to interact, ready for users, systems in real time. We've seen this with models like OpenAI's o1 DeepSeek. This shift to inference first is precisely what makes AI agents viable on a massive scale, like right now.
Okay. And that shift really sets the stage for what feels like the next frontier, the world of AI agents. We're moving beyond just asking an AI, draft this email. We're now talking about the power of an agent handling complex multi-step processes all by itself. Imagine telling an agent, run a campaign, grab the customer list, draft the email, send it for approval, and then ping me when the customer responds.
Yeah.
That feels like a massive leap, right?
It absolutely is, a huge leap. And this isn't some far-off future concept. We're already seeing tangible, real-world impacts in businesses today. Some companies are reporting like 20% revenue increases from sales automation using these agents.
20%, wow.
Yeah, and support response times getting 90% faster, just incredible improvements. And generally, companies are saving time anywhere from 50 to 75% when they deploy agents for certain tasks. So this isn't just theory. It's already profoundly reshaping how businesses operate, turning those tricky multi-step tasks into smooth flows.
Okay, so our mission for this deep dive is clear. We're going to explore exactly what these AI agents are. We'll dive into their impact, which sounds pretty profound already, and most importantly, show you how they're actually built, drawing insights from the source material you've provided. Let's unpack this. So with all this talk of powerful AI agents, the big question is, how do you actually put one together? If you sort of crack open an AI agent, look inside, you'll generally find it's built on 4 core pillars, 4 foundational components. The first is the client.
Right, the interface.
Exactly, the interface, how you, the human, interact with the agent. Think of it as the front end. It could be a voice interface using tech like WebRTC, that's the stuff behind video calls, combined with speech-to-text models to, understand what you're saying, or more commonly maybe, it could just be a familiar chat UI.
Then number 2, you have the AI itself. This is the reasoning piece, the thinking part of the agent. Typically, it's an LLM, a large language model. It figures out the logic, understands your intent, and decides what actions to execute next based on the tools it has and the information available.
Okay, so AI is the brain. Then following this, we have the workflows component. If the AI is the thinking part, you could say the workflows act as the executive branch.
That's a good way to put it.
They actually carry out the AI's decisions, keep track of what's been done, what hasn't, and manage the overall process, making sure everything happens in the right order.
And finally, pillar number 4, the tools. It's not enough for the AI to just decide what to do. It needs access to the actual capabilities to take those actions. These tools can be anything, really. Web browsers, APIs for external services like Salesforce or Stripe, internal company services maybe, or even those specialized knowledge bases you mentioned. Vector databases.
Right, vector databases. Those allow the agent to quickly pull in relevant context like customer history or product details.
Exactly. So it can make much smarter, more informed decisions in the moment.
Okay, so let's dive a bit deeper into that tools component, because this is where things get really interesting and where we've seen big advancements. Recently, there's been a lot of buzz around MCP, the multi-client protocol standard. Anthropic introduced that back in November, right?
That's right. And what's truly fascinating here, and maybe the sort of missed headline, isn't just that MCP lets humans talk to LLMs using natural language to expose APIs. The really significant thing is how incredibly good LLMs have become at tool calling.
Tool calling, meaning the AI figuring out which tool to use and how.
Precisely. This wasn't really the case even a couple of years ago if you tried playing around with it. It was clunky. But now, they are remarkably capable of understanding your request, figuring out which tool is needed. Maybe it's a calendar API, maybe it's a database query, and then knowing how to structure the call to that tool correctly. This capability is what really unlocks the power of agents. It lets them act autonomously in the digital world.
Okay, that makes sense.
And MCP itself, it respects a traditional client-server architecture. So you can have multiple different clients, maybe a web app, a mobile app, a Slack bot, all connecting to a single MCP server, single agent brain, if you like. And the core concepts of these MCP servers include things like resources.
Resources, like files or database records, data the agent works with.
Exactly. File contents, database records, user profiles,
Yeah.
the data it can access or change. Then there are prompts. These help you define how you want others to interact with your agent. You can build in nuances about how your system works, its specific role, personality maybe.
So you can customize its behavior.
Right. And you give it access to tooling, which is how you actually connect user queries or the AI's decisions to those specific external or internal tools we talked about. And finally, there's this concept called sampling. It's kind of an interesting idea. It's meant to be a sort of internal shorthand for the LLM's thought process. But honestly, while the theory is cool, we haven't really seen it widely implemented in production agents yet. It's still a bit more academic for now.
Okay, so resources, prompts, tooling, and maybe sampling down the line. That sounds powerful. But building all this MCP stuff, it involves some pretty complex plumbing underneath, doesn't it? You mentioned the transport protocol, often over secure WebSockets like an encrypted phone line, you said, and then integrating with identity systems like OAuth for logins. That stuff can be a real headache for developers.
Oh, definitely. OAuth alone can be a nightmare.
So is there a way to kind of abstract away some of that complexity, like a fast track to getting these agents up and running without wrestling with low-level protocols?
Absolutely, and that's exactly where Cloudflare's new Agents SDK comes into the picture. You can think of it almost like a cheat code for simplifying agent development. They released it a few months back. And yeah, confusingly, it shares a name with a recent OpenAI release, but they actually work really well together. What's super valuable about Cloudflare's Agents SDK is that it gives you a lot of this MCP functionality right out of the box.
Out of the box, like what specifically?
Well, you can use it to run MCP servers easily. It comes with a built-in MCP agents class. And this class handles things like OAuth integration, the secure transport layer, even HTTP streaming for responses, all just integrated. So if you're someone who really never wants to touch OAuth setup again, this is definitely worth looking at.
Okay, that sounds incredibly helpful for simplifying the security and communication side, removing a lot of those infrastructure headaches. But, nothing's ever a perfect silver bullet, right?
Ah.
Are there any scenarios where this approach might introduce maybe new complexities or where a developer might still need to think about, say, a more traditional database solution?
That's a really great question. It brings us to the core innovation here, I think. Integrated state management. This is powered by Cloudflare's durable objects.
Durable objects. Okay, what are those exactly?
Think of a durable object as a specialized kind of serverless function, but one that's built to remember things inherently. Unlike standard serverless functions that basically forget everything after they run, a durable object sticks around. It holds on to its unique memory or state for a specific task or a specific conversation thread.
So it has persistence built in.
Exactly. So if your agent needs to pause, maybe it's waiting for a human to approve something, which could take hours or even days, it can just pause and then pick up exactly where it left off later with all the context intact.
Yeah.
You don't need to set up and manage a separate database just to store that temporary state.
That seems like a huge advantage. Less infrastructure to worry about.
It really is. This design lets the agents scale automatically. They run geographically close to your users or the AI model, and it significantly reduces how much you, as a developer, need to think about infrastructure at all. It cuts down on a ton of boilerplate code. Now, to your point about databases, sure, if you need massive long-term historical data archival, maybe you get a traditional database still makes sense. But for managing the active state of an ongoing agent interaction, durable objects are often a game changer. Plus, the SDK also bundles in real-time WebSocket communication, which makes building chat interfaces much easier. And it has React integration hooks for front-end development and basic chat capabilities too.
Okay, let's make this more concrete. Can we walk through an example like deploying an MCP server on Cloudflare, maybe, let's say, for a book recommender agent?
Perfect example. Yeah, you could define your MCP class, have it extend the MCP agent from the SDK. You'd set an initial empty state like no preferences known yet, and then you'd add tools. For instance, an genre tool.
Okay, so I could tell it, hey, I'm a big Patricia Highsmith fan. I like thrillers.
Exactly. And you'd use the genre tool, maybe passing in thrillers. That preference thrillers get saved directly into the durable object state for your specific agent instance. And crucially, that preference persists across all your future interactions, no matter how you connect. Whether you talk to it from your phone later, or your desktop, or maybe even a smart speaker client someday. The state is tied to the agent, not the client session.
Got it. Persistent memory.
Right. Then you'd have another tool, say, Get Recommendations. This tool would use personalized prompts. It would look at the state, see thrillers saved there, maybe see books you've previously said you read, and use all that context to generate much better tailored recommendations. And because the memory persists, the recommendations just keep getting better and better over time as you interact more.
And how hard is this to actually deploy?
That's the other striking part. It's incredibly easy. There's literally a deploy to Cloudflare button in many cases. You can often get your initial MCP server, your basic agent, up and running in like less than a minute.
Seriously, under a minute.
Yeah, for a basic setup, it's designed for rapid deployment. And this isn't just for hobby projects either. Major companies, Atlassian, Asana, Stripe, Intercom, they're already building their own MCP servers in this exact way. So if you decide to go this route, you're definitely following a well-trodden path. It's becoming quite standard.
Okay, that covers the tools and the AI reasoning and how to simplify deployment. But a powerful agent isn't just a brain with tools. It also needs that sophisticated way to manage how the tools are used, especially when tasks stretch out over time and maybe a human needs to get involved. Which brings us back to workflows, and specifically the challenge of coordinating these long-running, what you called human-in-the-loop tasks.
Indeed. This is a really crucial piece for many real-world agent applications. Automating might take seconds, maybe minutes, for complex chains, but human responses, they can take minutes, hours, days, potentially even months in some business processes. So you absolutely need systems that can gracefully pause a workflow and then reliably resume it once that human task is completed.
And that involves more than just pausing, right? You still have technical challenges.
Oh, yes. You still have to think about managing potentially long-lived WebSocket connections if you have a chat interface. You need robust state persistence. We talked about durable objects helping there. You need reliable retries if something fails mid-process. And you need it all to scale horizontally if you have many users. Let's look at a real-world use case, maybe one built with Knock. They're a notification management company. Imagine a credit card approval agent.
Okay, credit card approval, how would that work?
So the process might start with a user requesting a new credit card, perhaps through a chat interface connected to the agent. The agent understands the request and decides to trigger an issue card action or tool. But issuing a card needs human approval first, right? So this issue card action is wrapped in a special kind of tool, maybe called require human input. This tool essentially delegates the approval step to an external system, in this case, Knock.
So the agent hands off the approval task.
Exactly. Knock then handles sending out the approval notifications, maybe via email, to a manager, a Slack message, an in-app notification in some dashboard. And the agent's tool call, the actual issue card part, is deferred. It pauses right there, waiting.
Right, waiting for the human. So thinking about a real system, my first question is, once that human clicks approve, maybe hours or days later, how does the system, especially if it's scaled out with many agents running, know exactly which agent instance and which specific pause task that approval belongs to? That seems tricky.
That's where the magic of something like durable objects really shines again, because each agent conversation or task has its own unique durable object instance holding its state. The approval message from Knock, when it comes back, can be routed automatically and instantly to the correct agent instance that's been waiting.
Ah, the routing is handled.
Yep. Handled by the platform. So the approval comes in, finds the right waiting agent. The pause tool call then automatically resumes right where it left off. The agent can now proceed to actually issue the card using another tool or API call. And then finally, it notifies the user, your card has been approved and issued.
That makes sense. But what about race conditions or errors? Like, what if the approval webhook gets sent twice or something? You wouldn't want to issue two cards.
Absolutely critical point.
Yeah.
This is where robust state management within the agent is vital. You absolutely don't want to approve or provision that credit card twice if, say, two approval signals arrive close together or a webhook gets retried. So inside the durable object state, you'd store the status explicitly. Maybe flags like approval requested, approval processed, card issued. When the approval comes in, the agent checks the state. If approval processed is already true, it just ignores the duplicate signal. This ensures the action is idempotent, meaning performing it multiple times has the same effect as performing it once. Super important for financial or critical operations.
Got it. State management prevents duplicate actions. That's key. Okay, so we've covered the AI, the tools, the workflows. Let's circle back finally to the client component. That's how users actually interact with your agent. You mentioned MCP offers flexibility here.
Immense flexibility. The beauty of using a standard like MTP is meeting users where they already are. For
Mhm.
instance, you might not even need to build your own UI, especially if your target users are developers. They might already be using tools like Cursor. That's a popular AI-powered code editor. Cursor now supports connecting to remote MCP servers.
Oh, interesting. So a developer could just point cursor at my agent.
Exactly. They import your MCP server definition, and boom, they can interact with their custom agent, use its tools right within their coding environment. No extra UI needed from your side. Similarly, major platforms like Anthropic's Claude and OpenAI's ChatGPT also support connecting to remote MCPs. So your users could potentially start using your agents almost instantly through those really familiar chat interfaces they use every day.
That drastically lowers the barrier to entry for users then.
It really does. Makes adoption much easier. However, if you do want more control, if you want to build truly unique or interesting agentic workflows, maybe a highly bespoke user experience tailored to your specific task, or a really slick voice interface, or integration with specialized hardware, then building your own custom application and your own MCP client gives you that ultimate flexibility and control.
And for voice interfaces, you mentioned WebRTC earlier.
Right. And tools like Cloudflare also provide utilities that help bridge the gap, translating WebRTC, which is the standard for real-time voice communication over the web, translating that into the WebSocket communication that your MCP agent server understands. So it becomes much more straightforward to build those custom voice-enabled clients that connect to your MCP agent.
Wow, what an illuminating exploration we've had today. It feels like we've covered a huge amount of ground. We've journeyed from understanding that just incredible rapid evolution of AI adoption to really uncovering the power of these AI agents and seeing their profound real-world impact already happening across businesses and, increasingly in our daily lives too.
Yeah. And we've broken down how you actually go about building these agents. We talked about those four essential building blocks. The client, how users interact. The AI, that core reasoning engine. The workflows for executing decisions and managing those potentially long-running tasks, especially with humans in the loop. And the tools, the actual capabilities, the APIs, the databases that let the agent take action in the world.
And it sounds like if you're looking to get started, that Cloudflare Agents SDK offers a really clear path, a way to get up and running quickly, maybe even in just minutes, as you said, because it's designed to abstract away a lot of that underlying complexity with the WebSockets, the state management, letting you focus more on the agent's intelligence and its unique capabilities.
Exactly. It lowers the barrier significantly. So maybe to leave you, our listener, with a thought to mull over. Considering these multi-step tasks that AI agents can now automate, and the way they can persist, context, remember things, wait patiently for human input, and then resume. What long, maybe repetitive or complex processes currently exist in your own life or in your work that can be fundamentally reshaped, or perhaps even completely transformed by applying these powerful new tools? What could an agent do for you?